Hello. So first off, I want to say that this tutorial is being recorded on December 30th, 2020. I hope you have a great New Year's. I know this year has been difficult for everyone, including me. So, just wishing you a happy New Year's. All right, on with the tutorial. So this tutorial is going to be about doing this where it's following the Gears of War aiming system that they made a video about, and I'm going to link it in the description, where they showed off the debug mode of it, showing like for the Nasher shotgun and how they do their aiming stuff. And it's essentially a bunch of boxes that they use traces with, kind of thing. And they just pick a point within that box to show the resulting spot of where to hit or where to send the bullet. So what's happening here, I'm just doing this, and I'll show you the debug view, and this is just to explain the concept of it. So I'm going to turn on debug view, all right? And the reason why it's not lining up with the UI is because I'm in this aspect ratio of like this viewport, but if I change it to new editor window, and I go to debug view, you can see the green lines. It pretty much lines up with where it's supposed to, all right? And if I shoot, it's all within those boxes, as you can see. So I'm going to go back to this. And the reason why is so I can hit if I turn on debug view, if I hit F8 on the keyboard, I can disconnect from the camera. And I can't do that in the play-in editor, or play-in window, essentially. So let me show you the example. So pretty much what's happening here is I'm not doing a bunch of box traces or anything like that. These are actually just debug lines. All of them are debug lines connecting to each other to show this view. But what's really happening is I'm providing vector offsets. All right, so it's really just an array of vectors for the points. So I have 1, 2, 3, 4, 5, 6, 7. I have 7 points that I gave as aim offsets. All right, and then I use another value called, it's a float value, which is the box size, the size of the box. And this is saying like the box size on the X and Y is the same, but you can modify the code afterwards to be like if you want to do rectangles or whatever. It depends on what you're looking for. So basically for each box, I'm not giving it points or anything like that. What I'm actually doing is using that center point, which is that middle line there, and I'm basically using the camera's up vector and the right vector to figure out how large the box should be. So I have a box value, and then I figure out using the up vector for the top of it, and then I figure out what the right is. And then I just combine those in different ways. So if I do the top plus the right vector, that means I'm going to get the top right corner. And if I want the left, what I do is the top vector minus the right vector, which gives it a negative value, which will push it over to the left side. And then it's the same thing for the bottom right and bottom left corners, except the top is negated and the right's also positive on this one, and then it's negative X and Y on this one. And that's all it is. Now the big thing is that how I'm getting it to rotate with the camera and all that stuff. If I go into this view, go into here, grab the camera component and rotate it. Well, the actor's actually not allowing me to, but basically it will rotate with the camera because what it's doing is it's using the camera's world transform to turn those vector points into relative space. So the points that I give it initially, those aim offsets that I was talking about, whoops, let me go back into here. Those aim offsets I was talking about, which is just an array of vectors, I'm giving them in relative space. So the first value is always going to be like 0, 0, 0 because I want it to be the center box. This one right there, sorry. This box essentially. So I'm giving it a value of 0, 0, and then the next array index is going to be like 50 units on the X and then 50 units in the Z or whatever, which is this one up here, or 60 or whatever. It depends. And then when I'm actually going to do these traces or like show this debug view, what I'm doing is I'm transforming it from the camera's relative space into world space. So 0, 0 at the camera is where the camera is. And then if I do like 50 units above it, you know, that's where this is, just like moved over there kind of thing. And these debug lines are just to show like the angles that we're trying to trace at. So another thing, when I'm tracing with the cameras and like trying to relay that to the UI to show like, hey, this box is hitting something, what I'm actually doing is I'm tracing at the corners and the center. So let me disconnect. So what I'm actually doing is I'm just doing line traces from the camera to the very end, so where these boxes are. So as you can see, they still show the debug lines, but each of these slices here is just to show, like, in case if you're trying to do like distances based on like damage range or something like that, you can do that where you can slice it, and I'll show you how to do that. But basically, because you're given like different points along it or whatever. But anyway, basically what's happening here is I'm not tracing on each slice, I'm just tracing from the camera to the very end. I'm not tracing this box to that box to that box kind of thing, because that would be bad performance really if you're just like tracing each section when it's doing the same thing as tracing from here to here. So, and there's really no reason, like there legitimately is no reason to have a box trace from here to here, because unless you're trying to do like an intersection in here only and not know about like the other intersections, but then that depends on your gameplay and stuff like that. And this is just to replicate the Gears of War aiming. So what I'm doing here is I'm just tracing at those corners that I showed you earlier, and then I'm tracing at the center point of the box. And that's just basically what I'm doing, is rinse repeating on that. So we're going to use a YouTube character, which is my version of the first person character template that I made, but I just ripped out all the fun stuff that made it do all these traces and stuff, so it's a clean example. So right now we can just move around, jump, and look around, and that's it. And I removed the VR stuff as well, just to make it more simple. So first let's go and set up our debug inputs. I've already done so in my project settings. What I did was I changed the reset VR key to debug key 1 and just made it the R key. And then I made a axis mapping called debug increase decrease. This is just so I can hold the plus or minus key and it increases or decreases the box size. All right. And I also use page up and page down on my keyboard just to, you know, if I can't reach the plus or minus, then I'll just use page up and page down, you know. So let's set up our debug inputs. So first, what we're going to do is debug increase, increase decrease. All right. And what this is going to do is just going to increase or decrease the box size, which is going to be a float value, as I said before. So we're going to make our new variable box size. It's going to be a float. Compile, save. And let's make the default value of that 50. All right. We're going to set the variable. All right. And we're going to do a plus, because this is always ticking. So it's either going to be 0, 1, or -1. Do our box size. And we're going to max this out to a value of 2. So that way it can't go below the value 2, because as I was testing with my version of the character that actually did the tracing and all that stuff when I was testing this and building it out, and also for my notes on the other page right now, on my other window, 2 was like the easiest that was the only one that I could see. If it went below that, it was like the UI was like overlapping itself and I just couldn't see anything. So 2 was the lowest value I could see visibly, but you can go lower. 0 would probably be the lowest. All right, so next we're going to set up our debug key 1. And this is just going to this is really just going to toggle our debug view. So I'm going to add another variable, and it's going to be a Boolean, and we're going to name it b debug aim traces. And for now, let's turn it on to true, so that way we can see it. So let's set it. And to flip it, we're just gonna drag this in and then do a not, because that will give us the opposite value of what it currently is, which is what we're gonna set it to when we press our key, the R key in my case. All right, and next we're gonna add our fire input. And we're gonna add tick. All right. And here what we're going to do is we're going to drag in our mesh 2p, which is our arms, get anim instance, which is the animation system, and then we're going to do montage play. This is what the tutorial, or well, not tutorial, but like the template project does, just so we can have something happen. All right, compile, save, and we're going to add two functions, trace from camera, and they don't have any inputs or outputs, so you don't have to worry about that. And the next one is going to be shoot from camera. So all this is just for example, like, you know, educational purposes, so you can understand what's happening. I don't recommend using tick, okay? But this is just for the example project and like for showing it for YouTube and all that stuff. It all depends on your project in actuality. You know, just be smart about it. If you're using tick, be smart about it. Don't always use tick because you don't need it, sort of thing. Just be smart about it. I don't recommend using tick for final products, for everything at least. All right, so next, let's first make our box showing up, so it's going to be like, you know, just a simple box that's right here. So for that, we're going to make a variable, and it's going to be a vector, and it's going to be our aim offset. Okay. And to make this easier, we're going to make a macro, and we're going to do get trace start. And this is going to be where our trace is going to start from. This is like where our start point is for shoot and trace from camera, these two functions. So we're going to drag in our camera, and we're going to grab out of this, get world location. And the reason why I'm doing it like this is because later on I'm going to show you what happens when you use like a sphere or something like that, which is just like the end point of the gun instead of the camera. So we'll just leave that there for later. Okay. So we're going to use trace from camera for now, just to show the debug views, all right? So aim offset. Actually, speaking of debug view, actually, let's get the world delta seconds. Let's multiply that by 2. And this is just for us to debug it and like see it. So this is going to be our debug draw time kind of thing. So temp underscore debug draw time. Just drag that up. Compile, save. All right. So now we're going to grab our trace start, and we're going to promote that to a local variable. And we're going to name that temp underscore, I don't know. Trace start. Yeah, let's just do that. Okay. So how do we convert aim offset, which is going to be a value of 0, 0, 0 purposely, like that, into like world space and like at the point where we want it? So if I do grab the camera component and then do get world transform, and then we're going to do transform location. If you're in C++, they made a function that is literally transform location or position. So you know, just letting you know now. This one is with scale. It doesn't matter. You don't need the scale because that one would be for direction. All right, so next, this basically will, actually, let's just draw it. So let's just focus on drawing a box first before we actually show it in the right position. So if I do draw line, because so draw debug line. So what I'm doing with each of those boxes, because if I do draw box, you know, it needs to have an extent and all this stuff, which is not what we want. Draw plane will also fill out the boxes, the inside of it, which is not what we want. I want to be able to see through it. So this is why I'm using lines. And this also helps me in terms of the math of just like figuring out each of the corners of the box, which the plane kind of does automatically, and it doesn't really allow me to have more control over that information. So how do we figure out the top left, or let me actually use comment boxes to show this. So remove that. So let's say this is our box that we want to draw. All right, this is our center point. Oops, let me do this and then change it to red just so we can see. All right, so here's our center point right here. Sorry, it's a little bit offset. All right, and we want to get to the top of it, and we need the right side of it, because when they're combined, they go to the top right. And if I do negative on the X, then it becomes top left, and so forth. But how do I get these where it's lined up? Well, so we have our box size, all right? So this is our box size, but this is the total value of the box. So the box size is going to be 50, so it's going to be the full box. All right. This is not what we want. We want to get half of it, because if we do half of that box, then it's a quarter, which the size of it is actually going to be the right amount, as you can see. So we're going to multiply this by half, and I'll show you the difference. So let me do this where we promote it to a local variable, and I'm going to name it temp box half size. Let's drag that to there. And the way we're doing like the right vector and this is grabbing the camera again and doing get up vector, get right vector. And that's basically our orientation. All right. You can change this however you want. It's basically like whatever you're using as like your start point and your forward direction, that's also where you should be, really, or depending on what your gameplay is, you need to figure out where you're going to be getting your up and right vectors, or right directions. Okay, so if I multiply, because right now we have our pivot, our center point, but we don't know like where the up vector and where the right vector is. So if I multiply the up vector by a float and drag in our box half size, now we have half of the box on the, on the vertical axis, and that's where we place it. And then we just repeat for the right side, which is going to be over here. Because if we use the full box, then it's going to double it, and it's going to be over here. Because imagine like you're duplicating this, and you're just trying to get, you want to get to this point right here, but giving it another box size is just going to duplicate it over to this far, which is not what we want. We want half. Actually, sorry. Probably be easier to show it the right way. So basically, if we just use the aim offset, or where the pivot point is, which is going to be this return value up here, that's going to be the red box here. And when we use the full box's size, it's going to duplicate an extra space. So the right vector would be here, or the up vector would be, one extra of these cube boxes over. But if we use half of that, then we get to the right point, which is the center. okay? But these are right now still in relative space. So the way we would combine them is just by adding it to our pivot point or our center point. So we add that and we add that. All right. So now we have our top right corner. And let me change this also. So we're going to make this, let's make it orange. Actually, let's make it purple. And the duration is going to be our debug draw time, as we set up before. And let's also make a variable for thickness, temp, local variable. And we're going to name it temp underscore draw thickness. All right. So now we've got the top right corner. How do we get the top left corner? Well, you know, x on the, this is the positive x value. If we just multiply by negative, it'll be over here. So, you know, let's do this. Let's duplicate this. Connect that into there for line start. Drag this to here for our add. We're going to add our positive up vector. And we're going to drag out of here and do negate. I was going to say negative. All right, so let's drag that to there. So now we have a line from this top left corner to the right corner. If I hit compile, save, and hit play, I don't see it, but there it is. So we have the top line of our box. Let's do that for the bottom for these ones. And let's make this easy as well, so, or at least easier to plug into each other. So we're going to do drag out of this, temp variable, temp top, let's say top right. And it's going to be really just a combination of the positive values Let me move these over. So top right, duplicate this, plug this into here, and then this into here. Promote to local, temp top left. Actually, let me move this over just to make it visually lined up as well. All right. So now how do we get to the bottom ones? Well, it's the same sort of thing. You just make the up vector negative, and then the right is going to be positive or negative depending on what you're trying to do. So negative, it's going to be for both of them. So we're going to add this, and then let's do positive. So that's going to be the right side, and promote that to a local variable, temp underscore bottom right. And then if we do another add, we're going to do negative and negative, because, you know, negative on the up and down is going to be at the bottom, and then negative on the left and right is going to be on the left. So temp underscore bottom left. And do this just so we can literally follow these lines, sort of. All right. So now that we've done that, we have our top right corner. And let's also save this out. So let's do promote to local variable, temp underscore box center. Sorry if this is a little bit convoluted in terms of the spaghetti. We'll clean it up in a second. So drag that there, box center. And let's delete these ads. All right. And if you want to, you can pause the video and just spend some time cleaning this up to be more readable for you. I completely understand. All right, so let's do that. All right, so now we've got our corners and we've got our center point, but they're all where the, essentially where the camera is, right? So let's add top right and box center, line start, and then duplicate that. Well, actually, let me use top left instead. It's top, let me try that again. So top right, box center, and this will be our line end. Drag that over, and we can just duplicate this. Duplicate these. And this time we're going to use bottom left for our start and bottom right for our end. All right, so now we've made our two lines that are horizontal. Let's compile, save, and test it, and eject out. See? So we have our two lines. We've got half of our box done. Let's do the other two. And it should be pretty simple to understand. So I'm going to plug this to here. Actually, let me do it below. Be easier. Duplicate you, line start, line end, and then replace bottom left. So we're going from our top left and then to our bottom left because we're doing our left side right now. Let's duplicate that. And this time it's going to be from our top right and then bottom right. But they're all always going to be added to our center point. So hit play, eject, and now we've got our little purple box. Ta-da! All right, so now how do we move those boxes over to where we want it to be aiming at? Well, it's pretty simple. When we're setting our center point, we can just drag this over, get our camera. Well, actually, yeah. So get forward vector, multiply it by a float, and let's make the second value a variable, not a temporary variable, or local variable. Let's make it a normal one. And let's name this aim distance. And we're going to add our transform locations result right here to the multiplication from our forward vector. And that's going to push it forward. Compile, save, and let's make sure our aim distance is an actual value. So we're going to change that to 1,000. Compile, save, hit play, and look at that. We can see it over there. If I hit eject, you can visibly see it's over here. It's separate from the camera. So if I possess it, look around. Now, just to let you know, it's literally just being moved over. So we're not actually checking if anything is colliding with it or anything like that. But we know our 4 points, which is important. Okay, so we've got our box over there. And we've got our corners and everything like that. Now, let's do our traces. So let me drag this chunk over. All right. And we're going to drag out of the points area where we were making our like corners and stuff like that. Let's drag out of here and do a sequence. All right. And we're going to do a branch here and hold control from then 0, drag it to a true, and drag our debug aim traces to here just so we can see it. Connect that there. Because we're going to be doing our line traces anyway, regardless of if you can see the debug stuff. All right. So we're going to do that again. And this time, just to make things easier to understand. All right, so we're going to do a for each loop. Make array. And we're going to grab one of these ends right here. There we go. And we're going to plug that into there. Actually, let's just grab each of them really quick. So top right, top center, yeah. So what we're actually going to do here is we're just going to get each of the corners. well, actually, we don't even need this. We can just do top left and top right as the next index. And this is just showing like in a more efficient way to write the code. It's just, I wanted to give you an example of what's actually happening. So, all right, so we've got our top right, top left, top right. Let's do bottom left, and then bottom right. Okay. Break that and disconnect it again. It was acting a little bit odd. All right, so let's add out of our for each and do box center. All right. Now the reason why we didn't do that with the line start and line end is primarily because like it's using a for each loop of just single vectors, but we need to know the start and end points kind of thing. So we can't be, unless you want to set up a map array and then do it that way, you can. I just did it this way. So I'm going to drag out of here, connect it to that. And then we're going to drag out of our loop body and do line trace by channel or Chanel. And then make that our endpoint for what we're adding to each other. And then our center point, or our start point, is actually going to be from over here, our trace start. Remember that earlier? So we're going to connect that to our start. And compile, save. Let's also turn on our debug type, draw debug type, and let's set it to for one frame. All right, compile, save, hit play. And look at that. Oh, I think we missed one of the corners. So bottom left, oh, yep. Let's do top left, my bad. All right, so top left, top right, bottom left, bottom right, cool. Compile, save, let's play. Ta-da! But our box is still over there. So if I eject, if I can go back to here and then I can eject out. Ta-da, see? It's still showing like where the box final point is and stuff like that in the debug draws. But we now have our 4 points. And if you want to add the center point, you can just add a pin. And since we know that the 0, 0 plus the center point is going to be, you know, where the box is, compile, save, hit play. Ta-da! So what you're doing here is essentially just like making the corners in the world space using the aim offset as your box center. So you're essentially just recreating this, but like over here using points within the box. And that it takes a second to kind of wrap your brain around, but if you mess with these values and stuff like that, it'll make more sense. If that makes sense. So yeah, let me try increasing this by 50. See? All right, so next, let me actually show you what happens if I move the aim offset itself. So I'm going to increase this by 50, and then I'm going to move on the y-axis 50 units, and then I'm going to leave x 0, and you'll see what happens. Actually, let me crank the y-axis to about 200. All right, compile, save. So as you can see, it's moved over like a bunch, but we haven't moved anything on the x, which you would be thinking like x and then y. But that's incorrect. What actually is happening is we're using the camera's right vector, which is, you know, our actual right direction this way. That's going to be our y-axis. All right, so this is really the y-axis, and then this is the z-axis, is up and down for our camera, because we're doing this in relative space. So the x-axis is actually the depth. So it's pushing it out farther. So if I set this back to 0, and then increase this by 1,000, but keep, let me put 0 as well for the Z. And then I hit play, it's already hitting that. It's actually pushed the box even farther out, okay? So you may be wondering, like, why are we using, you know, why aren't we just using X as the distance and stuff like that? You can totally do that. It's completely fine. You probably don't even need this part. But the X value, it's optional. It's sort of like an offset that you want to additionally add. But the aim distance is just so you can uniformly do it across all of them. All right. So we've got our box. We've got it, you know, colliding with stuff and hitting stuff and all that sort of thing. How do we get a random point within that box? All right. So if I go to shoot from camera and grab our aim offset. Well, actually, we don't even need our aim offset, I don't think. Let me look at my notes, sorry. Yeah, no, we do, sorry. Yeah, we do. So we're going to have to go back to our trace from camera, and we're going to drag, we're actually going to copy all these variables that we made at the start of the function. We're going to copy that, go to shoot from camera, and paste that in, because we're going to be doing the same sort of thing. So we're going to create local variable, create local variable, create local variable, and create local variable. Compile, save. All right. So next, this is the interesting part where it gives you a little bit more flexibility and control on like the randomness and like how to deal with like the spread of something if you're trying to shoot within that box and you want it to be within this certain area of the box, but you don't want it to like, let me actually visually show you. Be easier. So let me do this. That's a terrible box, but okay. Do that. No, sure, whatever. All right, so we've got our box here. Change this to red. All right, so what if we want to get a random point in this box? So we already know the box size, all right? So remember, 0, 0 is going to be the center point. Anything positive is going to be over here, and then anything negative is over here. And positive up, and then negative down, kind of thing. So let me duplicate this. Let me change this to a different color just to make it easy. All right. So we've got our yellow box is like our random point that we want to find within it. This is going to be essentially the positive max value of our box half. So this would be our positive version. And then over here, let me do this, -1. This would be our -1 version. So we would just pretty much do a make random, oh, let me do random float. We would pretty much just do a random float in range. Actually, it'd be easier if I do it this way. So our minimum would be the -1. Flip this. Which is going to be over here, -1, or multiplied by -1. So whatever the box half size is, which since we know the box size is 50, that's going to be 25. So this would be -25 over here. Like this is -25, or no, this corner. This corner is -25 on the X and Y, and this is +25 on the X and Y. But the whole thing combined equals a unit of 50, or 50 units. So what we're doing here is we're getting half of it, negative or +25 on the X, and then -25 on the X and Y separately. So I'm going to drag this out. I'm going to connect this to that. And then what we're going to do is we're going to make a vector. So remember how our aim offset, we had to be adjusting our Y and Z to actually mess with it. So Y is going to be our X-axis and Z is going to be up and down. So now we have our random point within that box, but now we need to you know, place it in the world space of where the box is in the world. Not just like, you know, we have it in a box, but we don't have it where it should be, which is pretty simple to do. So in this part here where we're doing our transform location stuff, we actually can just drag out of our aim offset and just add to it. We don't want to add it to our end result because it can kind of be a little bit odd when you're doing it in world space, but if you do it in the information initially, so like right now, this is 0, 0, you know, this is 0, 0 plus whatever random float is going to be within that box. Then we transform it out and then we just push it out. So we don't have to figure this stuff out in the world space. We can just do it relative space beforehand and then just feed it in through our system, our math, and it'll just spit it out to where it should be within the box in world space. And it kind of handles like whatever other edge cases we have. So now we have our point, and let's rename this to random endpoint. Whoops. And then endpoint. All right, so now we're going to just do a line trace by channel. And we're going to do draw debug for duration. And this is going to be our endpoint. And we already have our trace start here, so we're going to just drag this over to here. Okay. And let's do this, drag out, break hit result. Well, actually, let's just test it first to see that the draw debug works. Yep. Look at that. It works. That's where the box would be. And, well, actually, since we already made that debug key stuff, I can increase it. Ta-da. And it just handles getting random points in that box. And then all you have to do at this point is just adjust values within the random float and range stuff that's being fed in, and just make sure it's within this, like, you know, box size or whatever. So you can make sure it's, you know, clamped to probably the half size would be safer. But if you want to go like a little bit outside of it, you can. It's, you know, it's up to you, but you have like the tools available to you now to modify this. And then from here, let's draw a little spawn emitter. So spawn emitter at location. Let's do a little explosion. And I'm going to scale these down by 25.2. And our impact point. And let's do impact normal. Drag that there. And pulling method, let's do auto release so it handles itself. And if we want to make it so we hit a physics object, we can. So drag out of here. And let's do hit component is simulating physics. Yep. Let's do apply. Let's do impulse, add impulse at location. Our impulse value is going to be normal times. Let's do, I don't know, negative 50,000. All right, drag that to impulse, and then our location is our impact point. Drag that to there for actually running it. If it's a physics object, compile, save. Look at that. And then if I do this, it's pushing it. Look at it go. Ta-da! All right, let's turn off the debug mode for that, since we have our little visual effect that plays. All right, anyway, so we have our shoot from camera basically done. So that's about it, right? Just one box. You don't want to know how to do the other boxes, I'm assuming, right? Anyway, so let's figure out how to do it so we have like multiple boxes or whatever. And then I will show you at the very end how to do it, how to kind of set it up with the UI. The UI method I was doing was just for educational purposes. It's not meant to be like final product stuff. Something you should obviously look into of like how to get it to properly size with it, since you're going from world location into screen transforms and all this stuff, and it affects it differently at different field of views and like different aspect ratios and that sort of thing. So you're going to need to account for that. Anyway, so now we've got all the basic math for like doing these traces. Let's just make an array of the aim offsets instead. So that should be it, right? Just be done with it. Yeah, very easy. Yeah, can't really do that. So we have to figure out how to do this properly with an array of them. And that shouldn't be too bad. So all we have to do, let's go to shoot from camera because that'll be the easiest to explain. So we can just drag this all out, drag out our aim offset for each, and connect that. Connect the loop body to here, and then our array element plugs into that. All right, so that's done. And then if I go into the array itself, and let's add an index of 0, and let's add another index. Let's say our box size is 50, so let's say 75 and 75. If I hit play, look at that. All right, so the shoot's working. Now let's go to our trace. So we need to figure out what needs to be before the array and what needs to be before the for each loop, and then what happens after. So let's do our for each, and we're obviously plugging our array element into that. This stuff for the box size and all that stuff doesn't need to be set every loop body, so we can just do that beforehand. And now that we do need to know our box center every time, so we can plug that to there, that to there. Let's move this all over. All right, compile, save. Should be it, yeah. Ta-da! So another thing we need to know, which corners hit, at this point, like how do we know which corners, like how many corners are hitting something, you know, that sort of thing. So we need to know like the corners, we need to know how to essentially count out the corners and know for the UI. And also how do we show the debug mode for slicing between different sections of it. All right, let's do the corners first because the corners will probably be, knowing which corners would be easier. So since we already know we're doing like a line trace from them, we can just do this where we check. Well, actually, we don't even need to check it. So let's make another local variable. Let's name it temp underscore. I'm sorry, let me check my notes. Hits per box would be easier. Let's change it from an array to a single variable, and then we're going to change it to an integer. All right, compile, save, and we're going to go to our sequence and we're going to set it to 0 before we do the for each loop. And the reason why is because if we have different aim offsets, this is essentially our boxes. So this is box 0, box 1. So every time when we do one of these boxes, we want to reset this value to 0. All right, and then we're going to set this after we do our line trace, but we're going to drag this in, and we're going to do a plus integer, and we can actually just plug in to here. We can plug in our return value as what it's adding. And the reason why is because booleans converted to integers is 0 and 1. 0 meaning it didn't hit anything, 1 if it did. So every time when it's checking each corner, it does the line trace and it says, okay, did this corner hit anything? It did. That's a value of 1, so that means we got a corner hit. All right. And then when this is completed, how do we track which boxes are hitting something this frame? Well, we can use an array of booleans essentially. So we're going to add another normal variable because this is going to be tied to aim offset, and we're going to do aim boxes hitting. Let's do hitting, yeah. So we're going to change it to a boolean, and we're going to make it an array. Compile, save. And we don't want to have to do it where it's like aim offset, add in a member, and then go in here, add a member kind of thing. We want it to kind of magically do it automatically. So we're going to go into our event graph, going to go to begin play. We're going to drag our aim offsets in, and we're going to drag our aim boxes hitting. Let me look at my notes, sorry. All right, and all we need to do is out of our aim boxes hitting, call the resize function. This is going to size out the array to basically if you were just hitting this a bunch of times, or how many times like the aim offset is. So I'm going to clear that, and we're going to resize this, and we're going to drag out of our aim offsets, and we're going to do length. We should probably rename this from offset to offsets. There we go. Compile, save. So now we have our length of the aim offsets array amount, which is, in this case, it's going to be 2 array elements. And when you call the resize, it resizes it using that value. So if you're doing 2 array elements, it's going to go, okay, how many array elements do I have? 0. Okay, let's add 1. Is that enough? No. 2. All right, it says 2. Great. So we're going to plug that there. Compile, save, and let's go back to trace from camera. And really all we need to do now is drag out of this array, and then do set array element, and drag it to our completed. Let's get our hits per box and check to see if it's greater than or equal to whatever amount we want. So if we want only 2, if the minimum required amount that we need, if we need like 2 corners to hit something, let's just put in 2. And then, sorry, and then we set an item in here, and let's also check size to fit in case if like it's an extra array element that gets added to our aim offsets. And let's also make this a variable for array index. So temp current aim offset index. Let's do that. Current offset index. Drag that to index, because they should be the same amount in terms of the array size. Now you could also do is just do length and just plug that into there, and that would require all of them to hit, but you know, it's optional. So if we need all of them to hit, it'll say it. So now we know which boxes are hitting just by giving it a index, and we can just grab from this Boolean array instead of having to check, like, instead of setting up some struct or anything like that. You can totally do a struct too if you want. It's just, you know, it's optional. It's different ways of doing everything, you know. All right, so next, what happens if we're not doing our debug aim traces? Well, actually, another thing is, so we have our bottom left and bottom right and that sort of thing. All right, so let's move this down here. Sorry, I'm getting scatterbrained now. Let's reorganize a little bit so we have more space, because we're gonna need it. So next we're gonna do is slicing it. So I'm going to add a variable. It's gonna be an integer, and we're gonna name it slices. It's just gonna be a regular integer. Compile, save. And let's do 5 just for testing. Compile, save. So what's the best way to explain this? So what we're going to be doing is, let me use these boxes. So we've got our camera over here. And then we've got our final box, which is going to be over here. And let's say we have a box that's going to be over here and a box that's going to be over here, you know. So what we're actually going to be doing is we're going to be doing a for loop where it goes through each index of that for loop and divides whatever slice we're currently on. So if we're on the second slice or something like that, it'll be this one. What we're going to do is we're going to divide by the maximum amount, which gives us a percentage of 0 through 1. And then all we're going to do is we're going to lerp between the different center points. So we're going to lerp from our starting point to the center point over here, and we're going to name that our slice center. Okay. So this part where we're doing like the top left, top right kind of thing, that's going to be our endpoints. So then what we're going to do is for our debug draws, we're going to get rid of these parts, which are going to be top right, bottom left, top left, that kind of thing. But we're going to keep the center point. Well, actually, we're going to need to get rid of the center point too, because we're going to be changing the slicing center as well. So we're going to have another set of arrays, or another set of vectors essentially, which are just going to be the same thing that we did here, except we're just going to be doing lerps between each of the corners. So yeah, that's basically what we're going to be doing. Debug aim traces. So let's do our for loop. Let me delete this so we have more room. We're going to drag out here. Well, actually, let me connect this to this. And we're going to create the index as a local variable. So temp current slice. Plug that into our loop body. And then we're going to do a sequence. And the sequence is just to organize the code to be readable. So our debug lines are going to be actually in the then one, which is going to be happening second. Okay. And then up here in the first part, we're going to actually set our variables, but we're going to make another set of vector variables the same way. Well, not same, but like similar. So first things first, what we're going to do is we're going to grab our trace start, and just so you have an example of it, so we're going to do top left, we're going to lerp between, and the trace start always has to be at A, okay? So it's always going to be A in this case. And then we're going to drag in our current slice, and we're going to convert this to a float, Drag that out, and we're going to grab in our slices, do divide by current, and this will give us a percentage of 0 through 1, and drag this into alpha. All right, well actually let's do it for the center first, box center, it'd be easier. And let's create a local variable of that, temp slice center, because we need the original values for the actual tracing stuff and down here, so we need to keep that. So we do this, and then we just rinse and repeat essentially, where it's going to be like this, where instead of using the center, we're going to delete that, top left, slice top left, and rinse and repeat. I'm going to be quiet for a second while I just copy and paste this, so it'll be easier to pause the video and just kind of rinse and repeat for the different corners. Slice top right. Actually, another thing we could probably optimize, sorry. So another thing we could optimize is the the percentage, and promote that to a local variable, temp slice percentage, and we can set it right here, right after we do this, right after we set it initially. And then we can just drag this into here, and it's less nodes. So there's top right, and then we're going to do bottom right. Oops. Drag bottom left to here. Temp slice bottom left. Okay. So we have that. All right, next let's plug these into here. So we're going to do our center. Let's just drag our center in really quick for each one. All right. And then I remember from here we were doing top left to top right. And then bottom, and then the bottom corners to each other horizontally. So bottom left, and then bottom right. And then this side we were doing left side, so top left to bottom left. Oops. So top right, and then bottom right. Compile, save. All right, so that should be about it. Let's hit play. Oh, let me double check that it works. Hit F8. Right. Okay, so it's doing, sort of is and isn't doing it. Let me check what's happening. So our center, we're lerping from here to here using the percentage. Yeah, so target center. Let me check my notes really quick, sorry. Right, so I did something different. I'm gonna drag this, delete these for the top left and top rights and everything like that. So we were still, what I was doing here was still the same method of getting the up and right and everything like that, and then just sort of adding them together. But the value I was doing for the half size was actually being multiplied by that percentage. So the centers were correct, but let me grab this. All right. So the positives, let's do this where it's multiplied, float by float. And we're going to drag in our percentage because that's going to be a 0 through 1 value. Plug that to there. All right, so this was top right. This was top left, I think. Yeah. And then this was, I think bottom left is this one. And then bottom right. Compile, save, hit play. If I do this, there we go. Look at that. It's scaling it down linearly and everything. All right, so you may be wondering, all right, so we wrote 5 slices, so I only count 1, 2, 3, 4, 5 slices. Great, but why isn't it doing it at the beginning? Well, because at the beginning, it's going to be 0. So 0 divided by, that, it's going to be 0. It's always going to be 0. So it's not going to show up. And if you add an extra, if we increase the slices amount, it's just going to increase in that. So if we do 10, oops, eject, ta-da, more slices. But it's still going to, kind of stretch them out linearly. All right, so now that we have our slices, let's do this. You may be wondering about, like, initially when I was having the different colors for each box length, essentially. So why is it like all the same here? It would honestly be easier if I just showed you, but it's essentially keeping track of the previous loop iteration. So this is a little bit more messy, as you can see, but pretty much what I was doing was after I finished showing, like, doing these draw lines and everything like that, I was checking if the current slice plus 1 is, within the range of the amount of slices we're doing. If it is, I would just save it as our next slices, center, top, right. And then this is also like the long way of doing it. I don't suggest doing that. That's why I made it a little bit more simpler with just top right corners with all the corners. And then we were just adding those. But basically all I'm doing is just changing the debug color. And I just made it a variable. And that's all I did was just change the variable based on if it's equal to slices, it's going to be red, which is going to be the last one. If it's plus 1, if the plus 1 is equal to 1, that means it's going to be, and I did it for 1 because that was going to be our start point for the next one. But up here, if I did our current slice equals 1, it's going to be green. So the box is going to be green. And then the rest of them are going to be yellow, which is the default color. But the reason why I picked 1 is because if you do 0, that's going to be where the camera is, which is going to be this section right here where you're not going to see, well, the beginning section here, so it's not going to see like the boxes or anything. So there's no point in checking that. All right. So next what we're going to do is we're going to do since we have everything for knowing the points and everything like that, we're going to build out the UI for it. So in my test HUD, what I was doing was, let's create a user interface first. Sorry, I'm getting scatterbrain again. Let's name it WBP HUD. All right, compile, save. All right, so now we have the HUD made, the class at least. Let's go into our event graph of the character. And we're going to create a widget. And we're just going to grab get player controller for the owning player. And we're going to feed in our HUD. So WBP HUD. We're going to drag out of here, add to viewport. All right, so next, what I'm going to do here is I'm going to drag in a canvas panel. And I'm going to set this anchor to 0 and do size of 100. And let's make this a variable. Compile, save. All right, so now I'm going to drag in an image into it, and I'm going to make it not a variable. Now I'm going to change this anchor to the center at the top, and I'm going to change its size to what was it I put for mine? Let me see. Oh wait, no, I was using boxes, right? So what I can actually do is Control Shift and then this, and then change the size in the Y to value 5, and duplicate. And we're gonna do that for the corner, for all the corners. So that one, or all the sides, sorry. This one's gonna be 5 on this, on the X. And then this one, come on, there we go. All right, so I'm only doing it for one, but essentially the idea would be like you create multiple of them, and then you would pretty much you would just get the way I was doing it was you would create multiple at runtime, or the way I suggested is you would create one reticule or whatever, and then just have it spawn them in the HUD or widget or whatever, and then just place them where they should be using the position X and Y and that kind of thing. But this is using like what I set up. So look at my notes. All right. So first things first, we're going to get rid of these. We're going to use tick for this. Compile, save. Again, tick is not the best practice. Just putting it out there. So that way you understand. All right. So we need a reference to the character. So I'm going to make a new variable, my character. Actually, let's name it player. And we're going to change this to YouTube character, which is the character we've been messing with. Compile, save. And we're going to make it instance editable and expose on spawn. All right, we're going to go back in here in our YouTube character, and we're just going to right click on this and do refresh nodes. So that way we can get that. Drag out of here, input ourself. I'm kind of being lazy about it at this point because this is the end of the tutorial and I've been talking a lot, so my throat's kind of hurting. But all right, we're going to drag in player, and we're going to convert this to a validated get. So that way it's valid and everything, and we can just access it. And then what we're going to do is we're going to drag in our canvas. And again, there's a way of doing this dynamically, but I'm just doing this as a hard-coded thing. So we're going to do slot as canvas panel, okay? Because this canvas is within its own canvas, so it's going to have, this is its canvas panel. All right. Then we're going to set the size. I'm going to make vector. Plug that to is valid. Grab out of the player. We're going to do box size. We're going to grab that, and we're going to plug it into the X and Y. All right. Next. And you're going to have to adjust this depending on, you know, your whole setup and everything. This is just so you guys can have like a basic tutorial of how to set this up. All right. Next, we're going to drag out of this. We're going to duplicate that and set position. All right. We're going to drag out of this, do get aim offsets, get a copy. And we know index 0 is going to be 0, 0, 0, but you know, it's good to know. So we're going to break the vector. And this is, again, just me like hard coding this stuff in a way. I don't recommend doing this in your final product game. I suggest highly that you figure out your own method of like properly placing it to the screen to where it should be and everything. Since you have the center points of the box and everything like that, like this shouldn't be a problem. I'm just sort of throwing this in there as like an optional thing, and just so you understand like how to know which box is hitting what and everything. So make position, and I'm going to do negative on the Z, so multiply it by -1. And I'm just literally going off of what I did on my other HUD in this project. So that's position is set. And then what we're going to do is we're going to grab the canvas, get children, or get all children for each of them. And then we're going to cast this to an image. And set color and opacity. and we're going to do a select color. I'm going to drag out of this, get aim boxes hitting, get a copy. I'm also probably, yeah, I should probably make this a parameter. So right click, promote to variable, and we're going to name this box index. Yeah, let's do that. Drag that there. All right, so now we can just drag this to here. So if it is hitting something, we'll make the color red. If it's not, we'll make the color white. Or whatever, you know, it's up to you. All right, so if I hit play and turn off the debug view, hitting R on the keyboard, look at that. It's going green. Ta-da. And the other one's hitting stuff. And if I change the index, whoops, let's see, the value of 1, because we only have one other box. Look at that, it moved up there. And then if I do this, ta-da, and it's counting as two points have to hit it. And if we go back to, let me save the HUD. If we go back to our character, go to trace from camera, and down here where we were doing our line trace and setting the array, the aim box is hitting, we can just change this value to a value of 3, compile, save. You can even make this a variable if you want, it's up to you. So hit play. Oops, I did this in the wrong viewport, there we go. So if I do this, turn off debug view, it's hitting 2 of them, but it's not counting, and then 3 counts it as like, hey, we're, you know, looking at something. I recommend using 3 because, you know, kind of ensures that you're aiming at something, or at least tells the player that they're aiming at something. And then if you shoot, look at that. But the other one isn't hitting anything. And then if I move that up, see? It still is technically hitting it because it's like right at the edge of the box. So it's up to you, you know? And that's kind of the idea with it, is like you're just using traces in boxes and tracing to where the box is, essentially. But hopefully I made this tutorial like easy to understand. Like the math behind it isn't super complicated, but it is kind of like you need to understand a little bit of it. Probably the most important piece that I always think of it is like the transforming it from 2D to 3D is always the scariest. So the fact that this just kind of handles it for us is really nice, that we just use the camera's transform and all that stuff. Oh, that's right. I was also going to show you the what we do if we trace from a different point. So if we go into get trace start and change the world location from using the camera to the sphere, compile, save, and hit play. Now you can see that it does it like this. So, but if I go over here, and I want you to pay attention to the center box, this center box, all right? So it's counting it as hitting right here, kind of thing. But that's clearly not where the camera's aiming. And I just want to let you know about the differences between the aiming methods, you know. And you can always do a swap between them, where if you're zooming in like the Gears of War video does, where they zoom in, they use the camera, and then when they're not, they're using the gun. So this would be like normally how it is in Gears of War, and then when you aim in, it just swaps it to this. And I don't recommend doing like select and then whatever. I highly suggest you do this instead, where you're using a vector, all right, and make this a function or whatever. So if I check that true, it uses the camera, and then if I turn this off, it does that. Ta-da! So that's generally the idea behind it. And yeah, let me know if this video was helpful or anything. Yeah, have a great New Year's. Have a great rest of your day. Bye.